And so yesterday we wrote these definitions down. Today we're going to use what we know about independent and dependent events to solve problems. We're hoping we don't have to draw tree diagrams because they're a pain. So we're going to take what we know about probability and the fundamental counting principle and apply them to a new situation. So any of those things on the quiz that didn't make sense to you, you still need to learn because you can't do the next part without it. So ask questions early and often. When I have an independent event, I'm going to find the probability of each thing happening and I'm going to multiply. Because I could make a tree diagram, right? And we know on tree diagrams we have the same number of things, however many times we have our first choice. And so let's look down here at example 1. They're doing tiles and a spinner, independent, right? Tell me why those two things are independent. Why is this an independent event if I have tiles first and a spinner second? Kayla. They're separate things. I can pick whatever tile I want and it doesn't affect the spinner. And what's going to happen is we're going to try to find the probability that both things are a vowel. Well, what's the probability of getting a vowel from my tiles?
27.
Good. 2. I want 2 vowels out of 7 total things. Probability is what I want over the total number of choices. What if I spin the spinner? What's my probability of getting a vowel there? How many vowels? There are 2 out of 6 or 1/3. I'm going to highly recommend you reduce to lowest terms and look for common factors on tops and bottoms when we fraction multiply. So you take the probability of the first thing and the probability of the second thing and you multiply.
Well, that's easy. And what is that?
And so the probability that you get both vowels is only 2 out of 21. What I could do is I could do a crazy tree diagram. Do not write this down. I could write A, E, B, G, S, L, T. I could write all 1, 2, 3, 4, 5, 6. I could write 7 things, right? And then on my tree diagram, I could write all 6 letters. A, B, C, D, E, F.
You can stop right there.
Right? So I have A and A and E. I'd have 6 things here, right? I'd have E and A and E. So there would be 4 of them, 4 choices, where I have vowel and vowel.
So you list like the A and then the other ones like.
You could. You could.
Is that what
So there'd be 4 ways to get 2 vowels. I've got 6, 7 times. How many options will there be? If I have 6, 7 times. Because I'd have 6 branches. It'd be 42, right?
How do you get 78?
Because there's 6 here. 6 for A, 6 for E, 6 for B, 6 for G. 7 times, right? Because I'd have 7. Wait a minute. Didn't our thing just tell me there'd be 2 out of 21? It saves us all that work. Please tell me that we understand that when we multiply, it's like doing the counting tree, right? But you do not want to do this. It sucks. Okay? I'm with you, Mrs. Smith.
Yes.
We're going to do part of the assignment together. So we're going to do 1 through 5 on 452.
That's all we have to do today?
No.
Probably do.
No, that's what we're going to do together, and then you're going to work on your own. So, for number 1, it says, we're going to toss a penny and roll a number cube. We're going to find the probability. So I turned the page. We're doing this, so you write this down. Is this independent or dependent if I flip a penny and roll a number cube?
No,
It's what? Why is it independent? You're right.
Because they're 2 separate things and if you flip it, then
Yeah, they are separate things, and so they don't affect one another. So for number 1, we're trying to find the probability of getting a tail and a 3. What's the probability of getting a tail if I flip a coin?
1 to 2. 50.
1/2. And we're going to use fractions because we're going to fraction multiply. Okay? How many ways can I get a 3 on a number dice?
1 to 6.
1 out of 6. Look at us go. What am I going to do with my 2 fractions?
Multiply that.
Why?
You multiply across.
Yes. Numerator times numerator, denominator times denominator. Tell me why I'm multiplying.
Find out what it is in the small amount.
Good. How many total things there are? Because my tree diagram could start with a tails and a head, right? Those are my 2 choices first. And then I'd have 6 things here and 6 things here for a total of 12. And only one of them would be a tail and a 3. You do not want to keep drawing these tree diagrams. No. Do you? No. Not if you understand that that's why we multiply. And you do. We're good. I want you to do 2 on your own. 2 says it's the probability of a heads and an odd. Show me the work. Go.
What does it mean by odd?
So when I roll my number cube, how many odd numbers are there?
Oh. I still remember that.
Probability of getting ahead is 1/2. Probably there's 3 odds out of 6, but wait a minute, what do you notice? 3 6 can be what? Reduced to 1/2. Here's the deal, folks. Some 7th graders think that when I find a factor, it has to be on opposite ends. No. If you have a fraction you can reduce, you can, as long as it's a top and a bottom, you're okay. And so 1 times 1 is 1, and 2 times 2 is 4. That's my answer.